Hey team, and welcome to this explainer. I am absolutely pumped to guide you through today's session. Our objective today is absolutely crucial for your day-to-day operations out in the field. We are going to master the very first layer of fixed-line networks. By the end of our time together, you'll be fully equipped to confidently diagnose and, more importantly, fix network issues right inside the customer's property. Look, when a client's system goes down, you are the front line, and this explainer is your blueprint for getting them back online quickly and professionally. Okay, let's dive right into this. Here is our roadmap for today. First, understanding the CPN. Second, CPN core components. Third, cable crises. Fourth, switch freezes. And finally, a field troubleshooting summary.
All right, part 1, understanding the CPN. Let's set our baseline.
So what exactly are we talking about here? CPN stands for Customer Premises Network. Basically, it's the very first layer of a fixed-line network. You know how mobile networks have distinct layers? Well, fixed networks do too. The CPN encompasses every single piece of physical wiring, all the cables, and all those connected devices located entirely inside the customer's home or office building. As a field tech, I want you to look at the CPN as your primary battleground. This is your domain. And here's exactly why mastering this matters so much for you. Despite what clients might think, most data dropouts are not these massive systemic outages. Nope, they're usually caused by physical issues right inside the client's own property. Think of it like a chain. If a physical link breaks anywhere in this local chain, boom, the client loses their connection completely. Your job? Find that broken link. Moving right along to part 2, CPN core components. Now, what's really interesting about this is how data actually travels through the CPN. It starts at the user devices, so we're talking desktop PCs, laptops, IP phones, that sort of thing. That device connects to wall outlets. You know, those physical RJ45 network sockets built into the walls. But how do they connect? Through patch cords. These are those flexible Cat6 copper cables you're handling every single day. From that wall socket, solid copper cables run inside the building's tubes straight to the local IT room. It's essentially a high-speed physical relay race. Okay, let's talk about when things go wrong in part 3, cable crisis. Picture this scenario, right? You arrive on site and the client is just super frustrated about their network. They look at you and ask, what causes these intermittent internet drops and drastically slow speeds? As a technician, your mind should immediately jump to a few specific physical culprits hiding right there in the CPN. A lot of the time, you'll see this red flashing alarm state popping up, indicating an Ethernet link down, or the system will report just crazy high packet loss. Why? Because of physical cable damage. In a busy office, let's be real, patch cords take a beating. Customers accidentally step on them. They pinch them repeatedly under those heavy rolling office chairs, or they just pull them way too hard. This physical abuse literally breaks the tiny copper wires hidden right inside the cable's insulation. But hey, it's not always just accidental damage from the client. Bad crimping is a massive culprit here. If the RJ45 plastic connector isn't attached tightly and perfectly to the end of the cable, well, it creates a loose connection. And a loose connection means the copper isn't making consistent contact. That poor physical crimp, maybe it was rushed, maybe the tool was dull, will absolutely cause those exact intermittent drops and slow speeds your client is complaining about. So how are we going to fix it? Here is your go-to technical checklist. Step 1, disconnect the suspect cable and plug it straight into your LAN cable tester. If the lights show an open or short circuit, you've found your fault. Step 2, if it's a cable hidden behind a wall, cut the bad end off, carefully strip the wires, and use your professional crimping tool to punch a fresh, tight RJ45 connector. Step 3, if it's just an external patch cord, don't even waste your time trying to repair it. Just instantly swap that old cord out for a brand new factory-certified Cat6 patch cord that guarantees full speed. All right, on to our second major threat, part 4, switch freezes. Let's test your instincts with a really common, highly destructive field issue. You walk into a client's IT area, you look at their 8-port desktop network switch, and you notice all of the LED link lights are just flashing frantically at the exact same time. The internet is completely down. What do you think is the most likely cause of this total chaos? The answer? A loopback. Guys, this is a deadly technical trap. It almost always happens because a well-meaning but completely untrained employee finds a loose network cable and just plugs both ends of it directly into the exact same desktop switch. It seems totally harmless to them, right? But to the network, it is devastating. It triggers what we call a broadcast storm. And this brilliantly illustrates how a simple loopback causes a massive chain reaction of failure. Because both ends are plugged into the same switch, data packets get caught in this endless, infinite loop. This broadcast storm just floods the switch with nonstop data until the hardware literally cannot handle it anymore. The switch overheats, the ports totally freeze, and it abruptly shuts down connectivity for the entire office. It's wild.
But good news, the solution is actually super fast if you know what you're looking for. Step 1, inspect the switch, find that looped cable connecting the switch to itself, and unplug it immediately. Step 2, you absolutely must perform a power cycle. Disconnect the switch's power cable entirely, wait a full 10 seconds, count them out, and then plug it back in. Why? Because just pulling the network cable isn't enough. The power cycle is what actually clears the frozen memory cache, resets those ports, and allows clean data traffic to finally be restored.
Okay, let's wrap this up. Part 5, Field Troubleshooting Summary. Before we finish, let's lock in your 3 golden rules for your next dispatch. First, always isolate the local CPN before you ever start blaming the external service provider network. Remember, most of the time, the issue is right there inside the building. Second, your tools are your absolute lifeline. You should always carry a reliable LAN tester and a high-quality crimping kit in your field bag. I mean, you can't fix what you can't test, right? And third, be a consultant for your clients. Educate them to never plug random cables into their desktop switches. That stops those deadly loopbacks before they even happen. Mastering the CPN really just means paying close attention to these small physical details. That's how you fix issues efficiently, right on the spot.
I really want to thank you all for your focus and hard work today. By checking those patch cords, testing your pin configurations, and knowing exactly how to resolve network loops, you are providing absolute top-tier service. But you know, our journey doesn't end here. Once you've mastered the inside of the building, what happens when the problem actually is outside? Keep troubleshooting, team. Are you ready for Phase 2, where we step outside the property line to explore the access network and the mysteries of the last mile? I'll see you in the next explainer.